learned about chemical equations. They are the representation of chemical reactions with the help of symbols and formulas of the substances involved in the chemical reactions. So it is very important for us to learn the symbols and the formulas of the substances involved in a chemical reaction so that we can write down the chemical equations easily. Okay, now let's talk about elements. Elements are just made up of one kind of particles and they are represented by symbols. Whereas compounds are made up of elements only. When elements combine chemically, they form compounds. And compounds are represented by chemical formulas. So once we learn the symbols and chemical formulas about elements and compounds, we can easily write down a chemical equation. Let us begin seeing what are elements. Elements like sodium, it is represented by the symbol Na. Chlorine is represented by the symbol Cl. Oxygen represented by O, hydrogen represented by H, nitrogen represented by N, and so on. All these are elements because they are made up of one kind of particles, and we have 118 elements around us. Now when these elements combine chemically, for example sodium and chlorine combine chemically to form a compound sodium chloride whose formula is NaCl, 1 Na 1 Cl. Then hydrogen and oxygen combine to form a compound water which requires 2 hydrogen 1 oxygen. And nitrogen and hydrogen can also combine to form a new compound, that is ammonia, which requires 1 nitrogen and 3 hydrogens. So these are the chemical formulas of compounds and these are the symbols of elements. Now these elements which are represented by symbols can either be metals, non-metals or metalloids. Let us see how these elements react in different manners to form compounds. We've already discussed that elements are made up of just one kind of particles, and these particles are called atoms. We've already learnt about atoms in our previous classes. We know that atoms are made up of 3 different things. Recall what are those things. We know that atoms are made up of small electrons, small protons, and small neutrons. Now electrons are negatively charged, protons are positively charged, whereas neutrons have no charge, they are neutral. Number of electrons and number of protons are always equal in an atom. That is the reason why an atom is electrically neutral. And because it is electrically neutral, the metals, non-metals and metalloids which are elements are also neutral because they are made up of neutral atoms. Let us begin seeing how metals react. Metals react by donating electrons, and after they donate electrons, they become stable. Either they gain octet state, that is 8 electrons in their last orbit, or they gain duplet state, that is 2 electrons in their last orbit. This is how metals become stable. Okay, now let's talk about a metal. Let's take the example of sodium. Sodium is represented by Na. Now sodium initially is made up of atoms, and the atoms of sodium have 11 electrons and 11 protons in them. Now sodium, to be stable, will donate electron, and it donates 1 electron to be stable. Now what do you think sodium will be left with? Now sodium will be left with only 10 electrons, but the protons are still same, that is 11. That means we can say sodium's positivity is more than negativity right now. So that means it will gain a positive charge. Because protons are more than electrons by 1, sodium gains a positive charge. Let us take one more example. Suppose aluminium. Aluminium is a metal represented by the symbol Al. Initially, aluminium is made up of atoms having 13 electrons and 13 protons in them. But to be stable, aluminium reacts and donates electrons. But how many electrons? It donates 3 electrons. And after donating 3 electrons, what do you think aluminium will be left with? Aluminium now will be left with 10 electrons and protons are still 13. Here, protons are more than electrons by 3. So, aluminium will gain a 3 positive charge because its positivity is more than negativity right now. Okay, now we've already learned that metals are made up of neutral atoms. So, right now these are neutral atoms. But then what about these? Now, these are charged particles. Are they atoms anymore? No. Now, these are called ions. They are not atoms, they are ions. Now, because these ions are positive in charge, they will get attracted to anything which is negative. So, during electrolysis, if we have 2 electrodes, negative and positive electrodes, these charged species will get attracted towards the negative terminal, the electrode which is connected to the negative terminal of the battery and which is known as cathode, due to which these positive ions are called cations. So these are the cations. Okay, now the number of electrons that metals donate become their valency. So sodium donated 1 electron, so its valency will be +1 because after donating 1 electron it is gaining a positive charge. And aluminium's valency will be what? Aluminium donates 3 electrons, so its valency will be +3, as after donating 3 electrons it gains a positive charge. And how do we name the ions which are formed? Now Na plus is formed by a sodium atom, so the name of the positive ions remain the same. So this is sodium ion right now, and this will be what? This is nothing but aluminium ion. So this is an aluminium ion. Let us talk about non-metals. Non-metals accept electrons to be stable. Let's take an example. We have oxygen, whose symbol is O. Initially, when oxygen made up of atoms, it has 8 electrons and 8 protons. And once oxygen reacts, it will accept electrons, and it has a capacity of accepting 2 electrons. So now what is the state of oxygen? After accepting 2 electrons, oxygen will have 10 electrons, but protons are still 8. So oxygen will have negative electrons more than positive protons by 2. So oxygen will gain a 2 negative charge. Let's talk about another non-metal, chlorine, which is represented by the symbol Cl. Chlorine is made up of atoms having 17 electrons and 17 protons. So once chlorine reacts, it will accept electrons. But how many? Only 1. Chlorine accepts 1 electron to be stable. So now chlorine will have 18 electrons, but protons are still 17. So chlorine will have a more number of electrons which are negative than proton by 1. So it will gain a negative charge, 1 negative charge. Let's talk about the valencies now. What will be the valency of oxygen? It will be 2 because it has accepted 2 electrons. But it will be -2 because it gains a negative charge. And what will be the valency of chlorine? Chlorine's valency will be 1 because it has accepted 1 electron, but -1 because it gains 1 electron and becomes negative. Okay, now let's name these ions. What do you think the names of these ions will be? If this is oxygen atom, once it converts to an ion, it becomes oxide ion. The name changes. So oxygen becomes oxide. Similarly, when chlorine reacts, it becomes chloride ion. Its name will change. So it is chloride ion. You have to remember that you have to put an IDE at the end for a negatively charged ion. Similarly, if we have sulfur, sulfur becomes sulfide, nitrogen becomes nitride, and so on. Okay, we've learned that metals react by donating electrons and non-metals accept electrons to be stable when they react. Let's take one example. Suppose we have a metal. Will it be able to react with another metal? Well, the answer is no. There will be no reaction taking place here. Reason is because both the metals will try to donate electrons to each other and none of them will accept, so there will be no reaction taking place here. But then suppose if we have a metal and this metal will try to react with another non-metal, will this reaction be possible? Well, think about it. Yes, there will be reaction possible and both of them will react with each other because the metal donates its electron and non-metal will accept that electron. Let's take another case. Suppose we have a non-metal. Will a non-metal be able to react with another non-metal? What do you think will happen here? The answer is yes, they will react with each other and form a new substance. But how? Both of them accept electrons, then who will give? Well, in such cases, non-metals have learnt a very good thing. They have learnt how to share electrons. So aren't they really brilliant? Okay, non-metals do react with each other by sharing of their electrons. Let's take one example. Suppose we have sodium. It wants to react with chlorine. Sodium donates one electron and chlorine accepts that electron because sodium's valency is 1 and chlorine's valency is also 1. So they form a new substance, a new compound. And that compound's molecule will be made up of one sodium and one chlorine ion because sodium has already donated electron and chlorine has already accepted that electron. How will we name this compound? Well, positive ion's name remains the same. So sodium will be sodium itself. But what about Cl? Chlorine is a negative ion, so its name will change to chloride. Thus the compound will have the name sodium chloride. Okay, now suppose if we have another example, we have a metal magnesium. Magnesium also wants to react with chlorine. But magnesium has the capacity of donating 2 electrons. Chlorine can accept only 1. So another chlorine atom will accept that other electron. So for magnesium to react with chlorine, one magnesium atom has to react with 2 chlorine atoms. And they become a new compound. And the name of this compound will be magnesium chloride. That is because the name of the negative ions change. Because in the compound we know that we have a magnesium and chloride ion. But the only difference here is we have one magnesium and 2 chloride ions in the molecule of the compound. Isn't it very tedious to always draw like that and find out the formula of the compounds? So for that we have an easy way. Suppose we have sodium Na and chlorine. Valency of sodium is 1 and chlorine's valency is 1. So when they react and form a new compound, their formulas can be detected by crisscrossing the valencies of the elements. So the formula of sodium chloride will be NaCl. Now suppose if I have to derive the formula of magnesium chloride. Magnesium is Mg. Chloride is Cl. Valency of magnesium is 2. Chloride's valency is 1. So the formula of magnesium chloride, when you crisscross, the valency becomes MgCl2. So isn't this an easy way? Let's take an example of a non-metal reacting with another non-metal. So we have carbon and oxygen. Carbon's valency is 4. Oxygen's valency is 2. Now in this case, first we will take the LCM. 2 1s are 2 2s are. Now when we cross multiply, we find out that the new substance that will be formed will have 1 carbon and 2 oxygens. This is carbon dioxide, where carbon and oxygen have shared their electrons to be stable. But there are certain cases like one sulfur reacts with 4 oxygen and forms a structure SO4, but still this is not stable structure. SO4 to be stable has to accept 2 electrons. That means it requires 2 more electrons. And once SO4 accepts 2 electrons, it will gain a negative charge. 2 negative charge, as we've already learned that accepting electrons gain a negative charge on the species. Let's talk about carbon. Carbon reacts with 3 oxygens. It forms a structure CO3. But the CO3 again is not stable. The CO3 also has to accept 2 electrons to be stable. So once the CO3 accepts 2 electrons, it gains a 2 negative charge. How do we name these ions now? These are negatively charged ions that we've already seen. To name these ions, it should be named like this. Sulf for sulfur, 8 for oxygen. So SO4 is known as sulfate. Then how do you name this? Carbon, C for carbon and 8 for oxygen. So the name of this is known as carbonate. Okay, so this is an ion which has 2 elements, but both the elements in combination have only 1 net valency. So such ions are called polyatomic ions. Let's take one example. Suppose we have nitrogen, it reacts with 4 hydrogen atoms, still not stable. Now this has to donate 1 electron to be stable. So NH4 will gain a positive charge. Now this is again a polyatomic ion because there is one single valency to the entire NH4. The name of this polyatomic ion is ammonium ion. What is it? Ammonium ion. Okay, now suppose if we have a metal calcium, it reacts with the polyatomic ion NO3. This polyatomic ion has 1 nitrogen and 3 oxygen, still not stable. NO3 requires 1 electron to be stable, so valency of NO3 is 1. Calcium's valency is 2. So once you cross multiply, you will find that the new substance formula will be Ca, but NO3 should be twice because the NO3 required should be 2 to accept the 2 electrons coming from calcium. How will we name this? Ca is calcium, okay, and NO3's name is going to be NITR from nitrogen and 8 for oxygen. So NO3's name is nitrate. So the entire compound's name becomes calcium nitrate. Okay, now let us solve a question. Translate the following statements into chemical equations and balance them. Here we have to use our knowledge of writing chemical formulas and symbols of elements that we just learned. Okay, let's start with the first one. It says hydrogen sulfide gas burns in air to give sulfur dioxide gas and water. How do we write hydrogen sulfide? Hydrogen is H. Sulfide is S. It is nothing but sulfur, and after coming into a compound, sulfur becomes sulfide, IDE at the end. Hydrogen's valency is 1, sulfide's valency is 2. So when you cross multiply, the formula of hydrogen sulfide becomes H2S, and because it is a gas, we will write G as the state. It reacts with oxygen as it is given in the statement that it burns in air, and anything which burns in air will react with oxygen because oxygen is a supporter of burning. Oxygen is always written as O2, remember, because it is a diatomic element. Now both of them react and form new substances. The new substances so formed are sulfur dioxide gas and water. Sulfur dioxide can be written as S for sulfur, O for oxide, because there are two oxides, so sulfur dioxide, SO2. And water is formed in this reaction, which is H2O. Water is liquid, whereas sulfur dioxide is a gas, so G. Now, we have to check if this equation is balanced or not. Let's see. Hydrogen on my left hand side is 2 and hydrogen on my right hand side is also 2. Fine. Let's check sulfur now. Sulfur on my left hand side is 1, but on my right hand side, okay, it is 1 again. Let's check oxygen. Oxygen on my left hand side is 2, but on my right hand side I have 2 oxygens here and 1 oxygen here, and the total oxygen on my right hand side is 3. Okay, so here if we have oxygen 3 and here we have oxygen 2, is it possible to balance? Is it possible to make this 2 oxygen 3 by multiplying something? Well, that's not possible. So in such cases what we can do is, instead of having 2 plus 1 oxygen, we can have 2 plus 2 oxygen. So total oxygen becomes 4, correct? So the total oxygen becomes 4. Then it is easy to balance oxygen on the left hand side. How is it possible to do all this? Before balancing, the first thing that we do is draw boxes around the formulas of reactants and products. What is the reason behind it? We've already studied that boxes help us not change the formula of the original reactants and products. Okay, now let's start balancing. For that, as we've already discussed, that we have to make oxygen as 2 plus 2. So we have to make this oxygen 2. For that, we have to multiply the whole H2O by 2. Now, both the oxygens have become 2, 2. So the total oxygen on my right hand side is 4. How do we make this oxygen 4 now? Already it is 2. So multiplying the oxygen by 2. So now my oxygen is balanced. But when I balanced oxygen, I disturbed hydrogen. Now hydrogen has become 2 into 2, 4. Initially it was 2. We multiplied it by 2. So it has become 4 now. And here hydrogen is only 2. So on my right hand side I have to multiply 2 to H2S so that hydrogen becomes 4. Now hydrogen is balanced. But while balancing hydrogen, I disturbed sulfur. Now sulfur, which was 1, I multiplied it by 2, so it has also become 2. Now how to balance sulfur here? In simple, just multiply 2 before SO2. Now sulfur has become 2. But while doing so, I have again disturbed oxygen. Oxygen here has become 4, 2 into 2. So it has become 4 oxygens here. But here, because we had multiplied 2, it has become 2 oxygen there, and total oxygen here we have is 6. So can we make this oxygen 6? Yes. Just have to do one simple thing. 2 into 2 oxygen was 4. So here we can multiply the oxygen by 3. Now the oxygen has become 6. Thus our balanced equation becomes 2H2S plus 3O2 gives 2SO2 plus 2H2O. Let us try to solve the second question. It says barium chloride reacts with aluminium sulfate to form barium sulfate and aluminium chloride. Let us see how to write barium chloride first. Barium is Ba, chloride is Cl, valency of barium is 2, valency of chloride is 1. So when we cross multiply, the formula of barium chloride that we obtain is BaCl2. Barium chloride reacts with aluminium sulfate. Now aluminium is Al. Sulfate, as we know, is a polyatomic ion, SO4. 1 sulfur, 4 oxygens. Valency of aluminium is 3, valency of sulfate is 2. So when we cross multiply, the formula of aluminium sulfate that we obtain is Al2SO4 the whole thrice. Okay, then the products formed are barium sulfate and aluminium chloride. How do we write barium sulfate? Barium is Ba, sulfate as we know is SO4. Barium's valency 2, sulfate's valency 2. When the valencies are same, we cancel them. 2 ones are, 2 ones are. So cross multiplying, the formula which is obtained is BaSO4. Then we have aluminium chloride. Okay, one more product obtained is aluminium chloride. Aluminium is Al, chloride is Cl again. Aluminium's valency 3, chloride's valency 1. So when we cross multiply, the formula of aluminium chloride becomes AlCl3. So the formulas the equation that we obtain by writing the formulas is BaCl2 plus Al2SO4 thrice gives BaSO4 plus AlCl3. And as we can see, the equation is not balanced. Thus, we have to balance this chemical equation. Okay, for balancing the chemical equation, what we do is we draw boxes around the reactants and products. Now, let's start balancing. Now, we can see that sulfate, the polyatomic ion SO4, is present on my left hand side and as well as on the right hand side of the equation. So to balance these equations having polyatomic ions, it is better to start with the polyatomic ion. Here entire SO4 is 3 times. Here entire SO4 is only 1 time present. So we have to balance this SO4 and make it 3. So 1 into 3 makes SO4 3. So right now entire barium sulfate is multiplied by 3, so my sulfate has become balanced. But while I was balancing sulfate, I disturbed barium. Barium has also become 3, but on my left hand side barium is only 1. So to make it 3, I have to multiply barium chloride by 3. And when I was balancing barium, chlorine got disturbed. It was 2 initially, but when I multiplied 3, chlorine has become 6. And on my right hand side, chlorine is only 3. So how to make this 3 chlorine 6? By multiplying the AlCl3 by 2. Okay, now chlorine has become balanced, but while I was balancing chlorine, aluminium got disturbed. Aluminium became 2. And when I check my left hand side, wow, aluminium is already 2. So aluminium is already balanced. Thus my entire balanced equation becomes 3BaCl2 plus Al2SO4 thrice gives 3BaSO4 plus 2AlCl3. The third question says potassium metal reacts with water to form potassium hydroxide and hydrogen gas. Let us see how to write this statement into equation 4. Potassium metal is K. It is represented by the letter K. It reacts with water, and water's formula we all know, it is H2O. They form potassium hydroxide. How do we write potassium hydroxide now? Potassium is K, hydroxide is OH. Valency of potassium is 1, hydroxide's valency is also 1. So when we cross multiply, we find that potassium hydroxide's formula is KOH. And hydrogen gas is also formed, so hydrogen is written as H, but in the atmosphere it is always in diatomic form, just like oxygen, so we have to write H2. Okay, now the next thing is balancing this equation. For that, the first thing is we have to draw boxes around the formulas of reactants and products so that we do not alter any original formulas. Okay, now for balancing, we choose the element which has maximum number of atoms. Here hydrogen is 2. So let's balance hydrogen. Hydrogen is 2 on the left hand side of the equation, but on the right hand side it is, okay, 1 hydrogen here and 2 hydrogens here. Total hydrogen on the right hand side is 3. What do we do in such cases? In such cases, what should be done is make odd to even. So in such cases, when we have 3 hydrogens, we can make it 4 hydrogens. If we have 2 plus 2 hydrogens. Then it is easy for us to balance 4 hydrogens on the left hand side. Now if this is 2, then how do we make this hydrogen 2? By multiplying KOH by 2. Thus total hydrogen on the right hand side becomes 4. So now it is easy to balance this hydrogen. Just multiply H2O by 2. So right now hydrogen is balanced. Both the sides it is 4. Okay, now oxygen. It got disturbed when I balanced hydrogen. Now oxygen has become 2. And on my right hand side, when I multiplied KOH by 2, oxygen has already become 2. That's great news. I don't have to balance oxygen now. Okay, now what is remaining is potassium. Potassium also becomes 2. Here potassium is 1. So we have to balance potassium. Potassium also becomes 2 now. So the balanced chemical equation becomes 2K plus 2H2O gives 2KOH plus H2. Okay, now let us learn the valencies of ions so that we can write down the chemical equations properly using the proper chemical formulas of compounds. Let's learn the valency chart. We have divided the valency chart into groups and each group has the same valency. So in my first group I have hydroxide, the polyatomic ion OH, fluoride. Fluoride is nothing but fluorine which has become an ion. So fluoride, chloride, that is Cl, bromide, that is Br. Bicarbonate, well we know carbonate is CO3 and bicarbonate is HCO3 which is also called hydrogen carbonate. This is an ion, polyatomic ion. Then we have nitrate. Again in nitrate, NITR stands for nitrogen and O stands for and H stands for oxygen. So nitrate is NO3. The entire group has valency 1. In this case it is -1 because all of them accept electrons to be stable. Now how do we learn that the entire group has valency 1 and the members of the group? Well, there is a tune of the poem Mary Had a Little Lamb and we are going to sing this group in a similar manner so that we can learn the valency. The song goes like this. Hydroxide, fluoride, chlorobromide, 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 hydroxide, fluoride, chlorobromide, bicarbonate, nitrate. Their valency is 1. So sing with me again. Hydroxide, fluoride, chlorobromide, 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 hydroxide, fluoride, chlorobromide, bicarbonate, nitrate. Their valency is 1. Now let's come to the second group. The second group has ammonium, the polyatomic ion NH4. Next is silver. Silver is Ag. Next hydrogen H, then potassium K and sodium Na. Now this group has valency +1. So we shall learn this group using the same tune. And this song goes like this. Ammonium aa gaya hai ke nahi, hai ke nahi, hai ke nahi. Ammonium aa gaya hai ke nahi. Their valency is 1. Okay, now let's go to the next group. The next group has magnesium, mercury, zinc, calcium, barium and lead. The entire group has valency +2. So all of the members have valency +2. How are we going to remember this group now? The song goes like this. Magnesium hoga zinc ka baap, zinc ka baap, zinc ka baap. Magnesium hoga zinc ka baap. Their valency is 2. Okay, isn't that funny? Now let's go ahead to the next group. The next group is oxygen, oxide, sulfide, that is sulfur S. Then we have carbonate, CO3. Then we have sulfate, SO4. This group has valency -2. And the song goes like this. OS CO3 SO4 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 OS CO3 SO4, their valency is 2. Okay, now let's come to copper. Copper's valency is 1 and 2. And let's come to iron. Even iron's valency is 2 and 3. So both copper and iron here have variable valencies. If we have to take copper's valency as 1, we have to mention that. And if we do not mention 1, we can just write the copper's name as cuprous. And if the valency of copper is 2, the name is cupric. Similarly with iron, if iron's valency is taken as 2, the name of the iron becomes ferrous. And if the valency is taken as 3, the name becomes ferric. And then the last one that we have is aluminium. So this group can be sung like this. Copper 1, 2, iron 2, 3, iron 2, 3, iron 2, 3, copper 1, 2, iron 2, 3, aluminium 3. So this is how we learn the valency chart, and I hope it is easy for you to remember the valencies now and form the formulas.